example 1.1.1 asks us to consider a sphere of solid gold. We know that the sphere has mass 100 kilograms, and the density of gold is 19.3 grams per centimeters cubed. So we know that density in general is mass divided by volume. And if we can find the volume of the sphere, we should be able to go between the radius and the volume quite directly. So you might think all I need to do is simply take the mass divided by the density to find the volume. Unfortunately, like the last example, our units don't match up. This is expressed in terms of grams, and this is expressed in terms of kilograms. So before we do anything in terms of an actual computation, we need to get these things to agree in terms of their units. Let's also introduce a variable r to represent the radius, and let's express the volume of this sphere in terms of r. This is something that's really important skill in precalculus, is introducing a variable to represent a quantity in question. I'm going to just label r here to say that we're going to find the radius r. So I have to choose whether to work in terms of grams or kilograms. If I write 19.3 here in terms of kilograms, I'm going to end up with more decimal points. I think I would rather just write 100 kilograms in terms of grams. So I could take 100 kilograms and multiply it by a conversion factor. In particular, there's 1,000 grams per kilogram. My kilograms will cancel, and that will give me the mass of the ball in grams. So I'm simply rewriting this formula here in terms of the given information. Density is 19.3 grams per centimeters cubed. My mass I've rewritten in terms of grams. And now my volume, I'm going to write my volume in terms of r. So I've included the units on each of these numbers. The 19.3 is grams per centimeters cubed. This 100,000 is grams. And I've left off the units on r. Eventually, what we'll find is that r will be expressed in terms of centimeters. Looking at what we have here, the grams are essentially already canceling. I can simply ignore the units for a second to solve for r here. And I need to put this centimeters cubed somewhere. I can really think of it as a quantity. I can think of multiplying the left-hand side and the right-hand side of this equation by centimeters cubed. And then on the left-hand side, my centimeters cubed will cancel, and I'll find that this right-hand side is now in terms of centimeters cubed. So plugging this into a calculator, we find that r equals, or sorry, this should have all been in terms of r cubed. So we find that r cubed equals 12. We find that r cubed equals 1236.96 centimeters cubed. I can simply take the cube root of both sides to find r. Of course, the big takeaway of this chapter as a whole is to pay careful attention to the way that units are behaving and the way that we can manipulate units.